All right, I think we're live. Hello, everybody. So I'm Dr. Ben Mertz. I have Dr. Helen Zhu with me over here.
Hi, everyone.
And then over off the screen, we have our TA, Chris. He's going to be monitoring the discussion board, specifically the live discussion board for this. So if you are on there, make sure that you're posting questions, and we'll try and answer those live. So we look forward to that. I know some of the questions have been posted already, and we'll try and get to those as we progress through, but Chris is going to help us monitor that. First of all, welcome to the course. We're excited to have you. This is a brand new course. It's our second offering of this course, so we've kind of ironed out some of the bugs, but it's an exciting course. It's a course that really involves understanding how to solve problems and thinking like an engineer. And so hopefully as you progress through it, you're going to see how we are not only teaching concepts, but wanting you to apply those concepts to different projects, even ones that have you solve problems that you're interested in. And that's really the point of this first project, the Devil's Project. We do want to remind you, though, starting off, if you want credit for this course, if you want to verify and do the so tomorrow is the deadline for ID verification. Some of you have already asked questions related to assignments. We don't have any graded assignments turning in until after that ID verification date. So after tomorrow, you should start seeing some of those assignments appear, and you can submit some of the things that you've already been working on for some of these assignments. So hopefully you'll take this course for credit, or at least get the certificate. And then remember that at the end of the semester, after you've completed everything and successfully completed the class, if you are ID verified, you do have the opportunity to earn college credit from ASU by paying the credit fee. So if that's something that interests you, if you're interested in earning some ASU credit, even now, make sure that you ID verify before tomorrow. So that being said, again, we're here to answer questions. So I see we have a few viewers on. So if you have any of those questions, make sure that you post them on the discussion board for this live forum, and we will try and answer those live. Chris, I know we had some questions already posted. Do you want to?
Yeah. One of the first things is someone would like you to discuss engineering as it relates to healthcare and improving the quality of life.
So there's a lot of different engineering disciplines, and there's a lot of different ways to approach some of these big problems. And, healthcare, health issues, there's a lot of different problems that engineers can solve within that broad range. If we approach everything as a problem, then the problem-solving techniques that we talk about in this class will be valid for any of these problems, including in the healthcare industry. There are majors that are specifically dedicated to health issues like biomedical engineering. So if that's something that interests you, you could pursue a degree in biomedical engineering and gain specialized skills within that discipline. So for instance, Helen and I both have engineering degrees. My background's in aerospace engineering, and I've specialized in aerospace engineering topics. And Helen?
Solid mechanics is my background. Yeah, I agree with Dr. Mertz that you can definitely specialize in, for example, biomedical engineering if you're interested in that field. However, if you major in any field, you can definitely help with healthcare problems. For example, the National Academy of Engineering has identified 14 grand challenges for engineers in the 21st century. And out of those 14, there are 3 that are directly related to healthcare and so health-related fields. For example, these 3 are to reverse engineer the brain, and to engineer better medicines, and to what's the third one? It's about informatics, to secure informatics and better organize bioinformatics. So all of these topics require not only background and technical knowledge from the field itself, but also many other different fields as well. So yeah.
Yeah, and even sometimes some of these majors or topics that you don't think are connected to the field can actually be used. And that's why we talk about making connections between different things. So for instance, I've seen a lot of you computer science guys on the discussion board forums in your introduction. Informatics, big data, there's a lot of information that we can get from sensors or even from a large population talking about health issues. If we want to identify genomes that might cause cancer, we need to analyze big data sets over a wide range of people with a lot of variations. And so we need computer science guys in the health field just as much as we need computer science majors. And you never know where things can happen. So as an aerospace engineer, I could work in a variety of different fields. I could work obviously with airplanes, rockets, those kinds of things that we typically think of. But don't forget that cars deal with aerodynamics. So I could work in the auto industry. In fact, I'm faculty advisor for a Society of Automotive Engineers, and we have an aero team that focuses on aerodynamics within that. Buildings experience loads from winds, and aerospace engineers are needed for things like that as well. Same thing, if we're talking about civil engineers, building engineers, between disciplines. And once you gain the basic skills in engineering, you can apply them to all kinds of different problems. So hopefully you see this as a class that teaches you things that can be used to solve any kind of problem, not just the ones that you may think of right now. So yeah, the health field, big field, a lot of really cool things happening in there. Hopefully you get a chance to explore that a little bit.
What are some of the most important qualities any engineer should possess to be successful? And what do the best engineers do differently that makes them stand out?
Yeah, we had a lot of students asking about how to be a successful engineer, which is awesome. To be thinking about that even now is very important. Obviously, engineers play a big role in society. We deal with a lot of major issues, and it's important to have technical skills. And we're not going to downplay technical skills. However, it's often the other things that will make you successful. We talked about entrepreneurial mindset this week. Entrepreneurial mindset is one of those things that we're trying to instill in our students because we think that mindset will produce better results in terms of our problem-solving skills. So we want you to be curious, to be looking at what is the cutting edge of innovation, to try and understand it, even when you don't necessarily understand it now. You want to be seeking to understand those things so that you can apply them in different situations. We want you to be making connections between things, maybe from other disciplines, and using that to solve problems in maybe different ways. And ultimately, the goal is creating value. So if you can always think of how you are creating value for your customers, you're off on a good start. It means that your products actually solve a problem. It means that you are making something that people will buy and want to use. And it means that you're not making junk, like I said in the video many times. But those are some of the skills or the mindset that we want you to think about. And we've kind of introduced that in this course as well. But I know that there's other skills that companies are looking for and that will make you marketable, and we'll hit some of those as well. And what's your take?
Yeah, so for example, a lot of the engineering problems are very complicated in the real world.
Yeah.
And to solve those problems, we definitely need people working together. And therefore, being able to work in a collaborative environment is very important for an engineer. And that's something that we also emphasize. And and skills such as communication skills, because as an engineer, it's important that you're able to solve a problem. It's also very important that you can communicate your ideas very clearly to others, to your client, and be able to sell your ideas. That's also a very important skill. And one thing, which is one of the highlights of this course, is that throughout the course, you will slowly build your e-portfolio, and that's a place where you could showcase a lot of the different skills that you gain throughout the course. And some of the skills are related to the technical side of things, but there are others that are related to what we call the soft skills that are also very important for engineers.
Yeah, that e-portfolio is like a repository of the skills that you're gaining from this course. And if you do this well, you should be able to share that with other people and show them what you've learned and the skills that you've developed throughout your time here in this course. These are valuable skills. Ali Bauman, who you may see in some of the videos, worked in industry for many years before coming and started teaching at ASU. And she brings a lot of that expertise, things that she was looking for in her company, or what they were looking for in her company to be successful. So hopefully you're paying attention to some of those skills that we're trying to teach in this class, and you're wanting to document those in the e-portfolio. Kind of piggybacking on what Helen was saying too, teamwork is something that's very important. And so we do want you to collaborate with one another in this class. We have students from all over the world, all different backgrounds, all different skill levels. Wherever you're at, you have something valuable to share with others in this course. We want you to do that. So make sure that you're responding to each other's posts on the discussion boards. It's very important that you do this so that we give each other feedback and are able to use each other's expertise and knowledge to help us learn and help us explore what problems are out there, but also what other people have seen as far as solutions, or maybe even broaden your understanding of how problems are different in different places of the world, and having a global perspective, which is something that's very important within the modern engineering field. We no longer are limited to a state or a country. We're now talking about collaborations between countries, engineering firms between countries. We're talking about solving problems that span continents, and we have to have that global mindset. And this is a great test bed within this environment to see other people from different areas around the world. And then also the idea that so teamwork is important, but also what was the second thing that you mentioned? That was
communication.
Communication, yes. Remember that engineers are paid for what they know. So what's in here, right? The skills that you bring, the advantage that you bring to a company, what they're paying you for is up in here. If you can't get it out, then that's not of any value to the company. So as you're thinking about, engineers make a lot of money. Why do they make money? Because of what you put in here, what you're able to do with what's in your head. And so you have to be able to communicate that. So communication is definitely an important part of engineering, and hopefully you can see that in this course. And we'll give you some skills to help you communicate more effectively in this technical field.
There's one more skill that I wanted to add as well, which is always willing to being willing to learn new things, because our world is changing very fast right now, and the kind of things that you learn like 5 years back would still be valuable. However, you also need to always look for what's going on in the world right now, and be willing to accept new concepts and learn new techniques and knowledge and all that. That's also very important, and that is also related to one of the 3 C's for the entrepreneurial mindset, which is to always be curious about your surrounding world and about what is going on.
So that's why we emphasize those 3 C's. What else we have?
Do you think it's wise for engineers to re-examine old things that have been designed and created, and do you think that they could use those to have new ideas for newer technologies?
Yeah, so the question revolves around, is it important to look at what was done in the past in order to innovate into the future? And the answer is yes, wholeheartedly yes. There's a whole phase of research in the design process that we talk about, right? And that research, part of that is looking at what other people have done to solve the problem. sometimes the solution is already out there. Sometimes the solution has been available, but maybe it hasn't been used in the correct way, or maybe we can think of other ways to use that solution to solve a different kind of problem. If we don't do that research, if we don't look back to what's already been created, we're not going to identify those. Also, if we do this design context review, or it's sometimes called a design context review. If we do this, if we look at what other people have done to solve the problems, oftentimes what we are able to identify are gaps, things that maybe the solution works, but it doesn't work as well as we would want it to, or it doesn't work in certain situations. And that's where we can innovate. We can identify opportunities to innovate within those different sections. So yes, by all means, look at what's out there, do research, figure out what those topics might be, those gaps might be, and that's where you get a chance to really innovate. I don't know if you have anything to add.
Yeah, that's a very good answer. It's also what I think for sure.
Okay, we have a question in the chat actually, and this person wonders, they're trying to get more into design and they're applying for a master's in design in universities abroad. How do you suggest they can build a strong portfolio to get into these universities?
So the skills that we're talking about and that we're documenting in those e-portfolios, a lot of those will be transferable. The word design is used in a lot of different fields. So we have graphic design, we have fashion design. There's all kinds of design out there, but ultimately design is about solving problems. We're focused in this class about engineering design. So we're approaching the design process like engineers. And so we talk more about the mathematical modeling, some of those skills to predict what will happen. Within any design that we might be doing, a lot of those steps in the design process are going to be the same. We're just going to kind of emphasize different things. So as you're thinking about the design process and breaking it down, realize that other fields of design utilize very similar processes, and hopefully a lot of this information will transfer over. And one of the things that we want you to be able to do is be able to communicate what skills you have and what you have learned in this class. And we do have some reflections in this class as well. So pay attention to those. Use those as opportunities to reflect on what you're learning and how that might be able to be applied in your specific design field. Again, it's about selling yourself and selling your skills. So when you're looking at trying to apply for different universities, be able to talk about what you're learning and how it can be applied in different situations.
And we also have 2 design projects in this class. And after you've worked through these 2 projects, you can definitely also showcase your work in your portfolio because it demonstrates that your work will demonstrate that you have the ability to actually apply what you've learned, apply the skills in the design process to actually solve real-world problems.
Yeah, I don't know how many of you are familiar with, what's the difference between bachelor's degree, master's degree, PhD kind of things. But, the way I like to describe it is a bachelor's degree is about learning things that we've known for hundreds of years. We've known this stuff for a while. We're just trying to catch you up to speed. A master's degree is about applying those skills you've learned as an undergrad to a new problem. So it's some manipulation of what we've learned into a new area. And so if you're pursuing a master's degree, you want to be able to demonstrate that you have a firm grasp of what you've learned in your undergrad and those basic skills, but then also that you're able to apply those in different areas. And that's exactly what Helen was talking about when she was talking about these projects and being able to demonstrate that you're able to apply these skills. The PhD is like generating new knowledge. So, it's stuff that nobody's ever heard of before. And so that's the next step. So once you've mastered being able to apply these things in different areas to a new problem, now let's learn something completely new and share that with the world. So if that interests any of you, we have PhDs, we've been through that process, but this is the first step in that. unless you really are grounded in the fundamentals, you'll never be able to really learn something completely new, which is exciting and awesome. And maybe this inspires some of you, just this starting step to maybe pursue some of those advanced degrees. So congratulations in wanting to get into a master's program. It's an awesome way of demonstrating skills, and hopefully, like we said, this class prepares you to do some of those things within the design field.
We have another chat question, which kind of relates to what you're talking about now. But do you think that engineering is a good fit for somebody who might not have really strong math skills, but shows stronger skills in design and problem solving? Maybe has more passions for those kinds of things.
I've been talking a lot. I'll let Helen talk first.
Okay. So mathematical skills definitely are important for engineers, because as an engineer, we actually apply principles of math and sciences when we solve problems. We don't use what we often call the hobbyist approach, which is a trial and error approach. Even though hands-on skills are also very important. Now we have we need to apply we need to have a strong foundation in order for us to apply that in a hands-on environment. So I personally still think that it's an important skill, though. It's great that you are definitely interested in the design and the application side of things. But personally, I just feel it needs to, those should be viewed based on a foundation.
Yeah, and if you're going to be an engineer, you're going to be developing those skills in your curriculum. So you'll be taking classes that build those skills. In this class, we focus on the engineering design skills, and that's applicable to everyone. So all of you can apply the engineering design process in some way. You'll notice that throughout this course, especially in the second project, we give you simulators, which allow you to basically do the kinds of analysis that you need to do without actually having to know the math. So, don't get scared. We're not talking about advanced math in this class, but if you wanted to develop those simulators like we did, then yeah, you have to understand the background. You have to understand the math, but to be able to use them, you can do that, right? The other thing that I really want to point out is that we're really talking about approaching problems like an engineer in this class. So when we talk about Imagine, Design, Engineer as the course title, imagining possible solutions is awesome. We want to be able to design, but when we talk about engineering, it's about bringing it into reality, to be able to take these wild ideas and bring it into the real world, and bridging that gap between an awesome idea and getting it out into the world. And as Helen said, some people approach that as a hobbyist and do a lot of different experiments, trial and error, those kinds of things. There's the IDEO video that we showed you in I believe week 2. The enlightened trial and error succeeds over the lone genius. That's an important part of engineering as well. We do experiments. We do try and figure that out, but we often do experiments grounded in the math fundamentals. So if you're not strong in math, maybe an engineering degree itself isn't for you, but you can still start thinking like engineers and apply that in a variety of different areas. So, we think that if you have an interest in baking, thinking about the entrepreneurial mindset and designing, a system that allows you to bake more efficiently, that's engineering at some level that maybe doesn't necessarily need the full college degree for that experience. So there's skills within engineering that anybody can apply. We don't want you to be scared off by the math at this point. But if this stuff really interests you, if you want to go deeper, if you're really curious about why things work and how they work and how we can use these these science principles, these math concepts, to make something from our mind go into the real world, that's where you really pursue the full engineering degree, and you take that next step into some of these upper level classes that we might teach at a college or university. So again, this class, we're focused on those basic skills that to get you start thinking like an engineer. The decision-making process, when we talk about decision matrix later on in this class, that can be used to help pick a house or choose between a car, or make tough decisions about, should I go route A or route B? These can be transferred into other areas, and you can take a systematic approach to making decisions, tough decisions. And so, like I said, those can apply in different fields. But if you're really interested in going the full engineering route, math and science is an important tool that we use to effectively design products.
All right. The student that asked about the master's programs is now asking if you could specify one or two ways to build a credible portfolio in addition to the e-portfolio from this class. What are some other things that you can do to make yourself stand out?
So again, what you want to do is you want to show that you're able to apply skills. So whatever the skill is that you want to demonstrate, show how you've used that in the real world. So if it's, for instance, project management, okay, whatever it is, find a project that you can manage, however big or small, and show that you were successfully able to handle that. Budgeting. If you want to show that you can handle financial decisions, show a situation where somebody gave you some money to manage and you were able to use that effectively to accomplish a specific goal. So when you're looking at portfolios, especially for like a graduate degree program, you want, or even just a job in industry, a more advanced job in industry, you want to be able to show how you've applied those skills. So just saying that you have a degree tells you that you've learned certain, benchmark things, but to take it that next level, to be really competitive, you want to be able to show that you've demonstrated those. So within the design aspect, I don't know exactly which kind of design you're talking about, whether, graphic design, those kinds of things, but create a portfolio that shows specific skills. And it should be clear that you're trying to demonstrate a specific skill.
All right. I'm out of questions from this session.
All right. So it sounds like we're out of questions for the initial session. If you continue to have them, like I said, go ahead and post, and we're happy to answer those. I thought we'd talk a little bit about the course and kind of what's coming up. So right now you're working on your Devils project. The purpose of the Devils project is really to apply the skills that you're learning, the basic design skills that you're learning, to a problem that you're interested in. And the first part of solving a problem is finding a problem. So as you're looking at some of these discussion boards where we're talking about, what problems do you experience in your everyday life, we're trying to help you identify things that you might be able to use for your Devils project. The next step, once you kind of narrow down a list, is to really dive into a single problem. Really dive into what is the root problem. So not just the symptoms, but what is the root problem, the thing that will break it wide open. That means coming up with a problem statement that's specific enough that you can solve, but also broad enough that opens up a variety of different opportunities. And we've talked about that in the lecture videos. That also means defining criteria and requirements based on customers' interests. You can do that by asking other people around you how they experience that particular problem, because that will help you gain insights into what you might need to solve. Or start posting on the discussion board some questions that other students can answer and chime in on how they experience that problem. Again, one of the beauties of having a course like this is that we have people from all over the world, a variety of different circumstances. They experience problems in different ways, and they'll be able to help you tweak and identify opportunities for some really cool designs. once we've done that, once we've identified a problem, we've jumped into and we understand the problem, then we get the fun part, which is, you know, brainstorming solutions. We get to come up with a lot of different ideas, and there's no bad solution. And we'll talk about ways that you might be able to generate lots of different solutions. We're also going to be teaching you a program called Fusion 360, which is a computer-aided design CAD program, a 3D solid modeling program. So you're going to be able to turn that idea into a representation, a three-dimensional representation of what you're thinking about, so you can communicate it more clearly and kind of see how it works. Now, we're just introducing this. It's not going to be a perfect representation. You're not necessarily going to have every single detail ironed out, but hopefully this helps you understand your solution a little bit better and be able to communicate that more effectively. Also, CAD skills are in high demand. So we wanted to teach you this really cool tool that opens up a variety of different doors for you, that if you continue to progress, if you continue to become an expert in it, will eventually be a really useful tool for solving some of these big problems. And then finally, to wrap up the Devil's Project, you're going to be creating slides for a presentation on your design, where we want you to highlight, how did you find your design? How did you identify an opportunity to design for? And then, what steps did you take in the design process? How did you create this really cool thing that you're going to show off at the end of the project? And then ultimately, we want you to justify, defend, did this actually solve your problem? How did it solve your problem? And maybe even how this is different than other ways that people have tried to solve the problem. So when you're thinking about a Devil's Project, really think about, what kinds of problems interest you. Try and narrow it down to something that's solvable. So like ending world hunger is a great goal, but is there a piece of that we can address that might be more manageable, that we can make incremental steps towards solving the larger problem? So try and get us a little bit more specific than some of these wide problems, so that you can really define the problem well. And then ultimately be creative. Let your mind go. Let it come up with as many things as you can think of, because you never know where that great innovation could come from. And if you really have done all this, if you've done a really good job in solving the problem and you want to take it further, like I said, this is only the starting point. You're going to come up with a conceptual design, an idea on paper. But if this is something that you want to pursue further, maybe you could use this as a springboard into an actual startup company. Maybe you could be the next entrepreneur that solves this really big issue and actually impacts people's lives in the real world. So once we get done with that, so that's a 5-week project, we're going to have our 10-week project, where we're going to be doing a disaster relief project. So you're going to be designing an airplane. That's right. You are going to be designing an airplane, and we'll give you all the skills you need to do that. But you're going to be designing this airplane for disaster relief scenarios. And we'll have lots of information on that coming up, but we're just trying to pique your interest at this point. So stay tuned. Make sure that you stay involved. Make sure you stay in the course, because it's a really fun project. It's a really interesting project, and we hope that you enjoy it as well. Did I miss anything at this point?
Yeah.
So again, this is the second time that we've run this class. It's a really fun class. Stay involved, stay connected. The best way to get the most out of this class is to make sure to stay active on those discussion boards throughout the entire thing. If you start not posting any questions, or if you stop responding to other people's questions, you're going to become more isolated, and you're going to feel that. So the best way to stick it out, to be able to complete it, is to stay on top of those deadlines. So make sure you're looking at that course schedule, make sure that you're following along and staying up with those deadlines, but also engaging with other students, because it's more fun to learn with other people, and to really value what other people have to bring to your problems, to your solutions, to your learning. It makes it more fun, and you're going to get more out of the course when you do that. So that's just my 2 cents. Hopefully it's useful to help you be successful in this course. Anything else?
Oh, well.
All right. So again, ID verification deadline is tomorrow. So make sure that if you are interested in getting a verified certificate, that you ID verify before tomorrow. If you want college credit for this, you must be ID verified. We can't extend those deadlines at all. Okay, so make sure that you complete those deadlines to ID verify if you so desire. Hopefully, this is a class that will open up some just different ways of thinking about problems. Hopefully, we're going to give you some skills that will benefit you in terms of solving those problems. And this class is meant to be fun. So we want you to be doing engineering. So whatever background you have, we do believe that you can apply these skills to solve problems, both in this class, but also in the world around you. And so we want to empower you. We want to encourage you. We want you to apply these skills and just see what you can do with them and kind of play around with them in that way. So we want you to really take the title of this course seriously. We do want you to imagine, we want you to design, and we want you to engineer those future solutions. So thank you for everybody who's tuning in. If you're watching this video not live, hopefully you'll be able to join us for our next live session. So that's going to be coming up a little bit later in the course. So pay attention to that. Make sure you're looking forward to that. And we look forward to interacting with you in the discussion boards on edX. So thanks again for watching and have a good day. See you later.
Thank you. See you later.
Bye.